Welcome to the Explainer. You ever stop and wonder how AI actually works? Like, how does it think? Well, it all boils down to code. So today we're going to pop the hood and look at the essential toolkit for any AI programmer. These are the absolute basics, the building blocks for everything from a simple chatbot to those massive neural networks you hear about.
I mean, you hear about all these super powerful AIs, right? But they don't just appear out of thin air. Nope, they're built, one piece at a time, using just a handful of core tools. So let's go ahead and crack open that toolbox and see exactly what's inside. What does every coder really need to know?
All right, first things first, every single AI project, and I mean every project, starts with the same exact problem. A giant pile of raw, messy data. You can think of it like a jigsaw puzzle that's just been dumped out of the box. Total chaos. So the very first tool we need is something to tame that chaos, to turn all that random noise into information an AI can actually make sense of.
Okay, so let's start with this right here, a sequence of 1024 random numbers. Right now, this is basically just digital static. It's that raw, totally unstructured mess we were just talking about. And AI looks at this and has no idea what to do with it. At least not yet.
So, if we want to do anything useful here, we've got to bring some order to this chaos. The very first job is to take this jumbled up line of numbers and shape it into something, well, something more organized, like a grid, something a computer program can actually navigate.
And for that, we use a really cool and powerful command called reshape. It's so simple. It takes that long, messy line of 1024 numbers and just folds it into a neat and tidy 16 by 64 grid. And just like that, bam, our data has structure. Now we have rows and columns we can actually do something with.
And this is why that structure is so important. Because now that it's in a grid, we can start to zoom in. We can literally grab a specific slice of it. You see this 8x8 square here? And just analyze that one little piece of the puzzle. It's way more manageable.
Okay, so we can look at the data, but now we need to understand what it's telling us. And this brings us to a really critical concept, mean versus median. You know, you probably learned about this in school. The mean, that's the average. It's kind of like a seesaw. If you have one really extreme value, an outlier, it can totally throw the whole thing off balance. See here, with that 100, the mean jumps way up to 27. But the median just finds the true middle value. It doesn't care about that outlier. For an AI, this is so important. It means one bad piece of data won't trick the whole system.
All right, so our data's in good shape, it's organized. Now it's time to give our program a bit of a brain. This next batch of tools is all about logic. It's about teaching the computer how to make decisions and how to repeat tasks without us having to tell it every single time. When you get right down to it, all programming logic is really just a bunch of forks in the road. This right here is a classic if-then-else statement. The program just asks a simple question, right? Is the product of 50 and 30 less than or equal to 1,000? In this case, no. 1,500 is bigger. So if that condition isn't met, it does something else, like return their sum. It's just a choice, go left or go right. And this is fundamentally how an AI makes every single decision.
But what if you need to do something, say, 1,000,000 times? Are you going to write the code out 1,000,000 times? No way! That's where loops come in. You just tell the computer, hey, repeat this action, and it does it for you. And you can see here, there are different flavors of loops, like a for loop or a while loop, but they can both get you to the exact same result, and they are incredibly efficient.
Okay, next up, you have to realize that not all data gets stored in the same way. I mean, think about it. In the real world, you wouldn't store milk in a paper bag, right? Well, in the world of code, choosing the right container for your data is just as critical.
So let's look at two of the most common ones you'll run into, lists and tuples. A list is what we call mutable. That just means it's flexible. It can be changed. Think of it like a shopping list. You can add stuff, remove stuff, change your mind. But a tuple is the opposite. It's immutable. Once you make it, it's set in stone. It's locked. It's kind of like a signed contract. It's a secure record that you know can't be changed. And here's the proof right here. Look what happens when we try to change that tuple. The program just stops and throws an error. It says, nope, can't do that. And this isn't a mistake or a bug. It's actually a really important safety feature. It's guaranteeing that some data just can't be messed with by accident, which is absolutely essential if you're building a reliable AI.
All right, let's talk about something that can literally make or break an entire AI project: speed. See, we're not just dealing with a handful of numbers. AIs have to process millions, sometimes billions of data points. And when you're working at that kind of scale, even a tiny bit of inefficiency can slow things down so much that the whole system just grinds to a halt.
So you might be thinking, does it really matter? I mean, computers are so fast these days. Does one little change in the code really make a difference? And you know what? That is a totally fair question. So, instead of just talking about it, let's put it to the test. Let's run an experiment and see for ourselves.
Okay, we're going to have a little race here. We're going to test 2 different ways to combine lists. And to make it interesting, we're going to do it 1,000,000 times. Method 1 is super simple, just using a plus sign. Method 2 uses a specific command called extend. On the surface, it looks like they do the exact same thing, but let's see what the stopwatch has to say.
And wow, the results are in and it's not even close. The extend method is almost twice as fast. Think about that. Over 1,000,000 operations, that one tiny choice in how to write the code saved a massive amount of time. This is the difference between a fast AI and a slow one. So why? Why is it so much faster?
Well, the reason for the speed difference is actually fascinating. See, the extend method is really efficient. It just takes the new items and tacks them onto the end of the first list. It modifies it in place. But that simple plus sign, it's actually incredibly wasteful. Every single time you use it, it creates a brand new third list from scratch. It's like, imagine you have 2 big stacks of paper and you want to combine them. Instead of just putting one stack on top of the other, you photocopy every single page into a new third stack. Now imagine doing that 1,000,000 times. That's what's happening here.
So let's just step back for a second and look at the awesome toolkit we've just put together. These really are the fundamental building blocks that you now have ready to go. So, to recap what we've covered, you now know how to take raw data and shape it into something useful. You can analyze it with a bit of statistical smarts, you can apply logic using decisions and loops, you know how to pick the right container for the job, and maybe most importantly, you get why writing fast, efficient code is absolutely crucial for building powerful AI.
And look, don't let the simplicity of these tools fool you. Seriously, every single AI out there, no matter how big or complex, is built using these exact same principles. So now, you have the starter kit, you have the foundational tools. The only question left is, what are you going to build with them?